Salam sejahtera, we are from Group 7 and now we are presenting our mini project with the topic Recirculation Aquaculture System. Our group consists of 4 team members, which are Ying, Zhi Xing, Jun Long, and Khairina Izzati. In this video presentation, it consists of 6 parts. The first will be introduction, followed by literature review, methodology, calculation, discussion, and conclusion. Problem statement. The aquaculture control system consists of several unit operations, namely sump tank, water reservoir tanks, fish tanks, and filtration tanks. The water from the sump tank is initially pumped to the fish tank by passing through a biological tank to supply the needs for the fish. Then the water is recirculated back to the sump tank again by passing through a mechanical tank run by gravity. Therefore, we are required to suggest a suitable type of pump based on the pump chart to satisfy the ideal water flow rate and recirculation factor calculated. Besides, we are required to calculate the entire water volume of this system and recommend the most suitable water recirculation factor in 1 hour and the water flow rate. In this project, there are several specifications need to be determined, including water volume for the entire system, water velocity, water flow rate, power of pump, MPHH, heat pump, major and minor losses in the piping network, and lastly, total head loss. The objective of this mini project is to analyze the entire water flow rate in the aquaculture system, to calculate the entire water volume and the water recirculation factor of the system, to calculate the water velocity, major and minor losses in the piping network, and lastly, to investigate the commercial pump available in the market and suggest a suitable pump in this aquaculture system.
Literature review. So, what is the meaning of pump? Pump is a machine or device used for raising, compressing, or transferring fluids. It is used in processing system, distribution system to deliver liquid from low pressure to high pressure location. This pump is required if an initial energy not enough to overcome a total losses exists in system. There are 2 types of pump, which is positive displacement pump and dynamic change pump. Positive displacement pumps are designed to ensure that any pumping action is forward, while dynamic pump impart velocity and pressure to the fluid as it moves past or through the pump impeller. The advantages of PDP pump is the less weight of pump for given capacity, it doesn't need priming, and it's suitable for less discharge with high pressure requirement. While for dynamic pump, it costs less for installation and maintenance, has small size and requires a small surface for installation, and the third one is can accommodate low to medium viscosity fluids. The difference between PDP and dynamic pump. There are 3 factors, which is performance, viscosity, and efficiency. For dynamic pump, the flow rate varies with a change in pressure. The flow rate rapidly decreases with increasing viscosity, even any moderate thickness, due to frictional losses inside pump. The efficiency peaks at a specific pressure. Any variations decrease efficiency dramatically. It does not operate well when run off the middle of the curve, and it can cause damage and cavitation. While for PDP, the flow rate remains constant with a change in pressure. Due to the internal clearance, high viscosities are handled easily and the flow rate increases with increasing viscosity. The efficiency is less affected by pressure, but if anything tends to increase as pressure increases.
Net positive suction heat (MPHH) is a measure of the pressure experienced by the fluid on the suction side of a centrifugal pump compared to the variable pressure heat of a fluid, and the formula below will be used to find the MPHH available of a pump. Cavitation is the condition which happens within the fast-moving liquid when the static pressure in the pump falls below the variable pressure of the liquid. Cavitation must be reduced and avoided as the bubble formed at the pump inlet may cause noise and vibration, reduce efficiency, and most importantly, it may cause damage to the impeller blades. In order to avoid cavitation, MPHH available must be greater than the MPHH required. The total head loss is the sum of major head loss and the minor head loss. Major head loss is the loss of pressure or head in the pipe flow due to the effect of the fluid viscosity near the surface of the pipe, while the minor loss is the loss of the pressure or head loss in the pipe flow due to the typical piping system.
I am Jun Long. Now I will like to continue the presentation with methodology. At the beginning of this project, we try to analyze the whole system to know how it was carried out and also the working process flow. Then, to get a better and deeper understanding, we go to the Eco Park in UTM to visit the Recirculation Aquaculture System. We had taken all the measurements including the diameter of pipe and water flow rate that required for the calculation later. Next, before the calculation, we had made few assumptions and all of our calculations will be based on the assumption made. The Bernoulli equation will also be applied in the calculation so that we can find the head pump. For the calculation part, first we measure the flow rate of the water in the system and we calculate the average velocity. We also determine the volume of water for the whole system. Next, we calculate the Reynolds number to determine the type of flow. The conclusion that we get is the flow is turbulent flow. We also determine the roughness and total length of the pipe. After that, we calculate the friction factor and loss coefficient of minor loss, KL, before we proceed to find the total head loss. After we obtain the total head loss, we proceed to find the head pump. After we obtain the head pump, we will calculate the power and also the net positive suction head (MPSH) of the pump. The MPSH need to be calculated so that we can prevent the incident cavitation of pump to occur in the system. Finally, we will use all the parameters that we get to select the most suitable type of pump that can be installed in this system to increase the efficiency of water flow throughout the whole system. The diagram shows the recirculation aquaculture system that our group chose. It consists of 4 water tanks, 4 small tanks, 12 fish tanks, a sump tank which contains a pump. Here are the details of the tanks, including the volume, radius, length and width, and the most important one is the water depth. That's all for my part for presentation. Next, I will pass to Lim Hong Yin to continue the presentation.
Okay, thank you, Jun Long. My name is Lim Hong Yin, and I'll continue with the calculation part. Okay, so before we move on to the calculation part, there are a few assumptions that we can make. The first one will be the water temperature you assume to be 25 degrees Celsius. The second one is that we assume the diameter for all the pipe in the piping system to be 25 mm. The third one is that we assume the CPVC pipe is used in the piping system. And the last one, we assume a constant water flow rate throughout the whole system. Okay, so now let's move on to our calculation part. So the first step is that we calculate the flow rate. Since we already measure the flow rate in the eco part, now we just need to convert the unit from milliliter per second into meter cube per second. And we'll get the answer to be 6.1316 times with 10 to the power -5 meter cube per second. And we need times with 4 as we got 4 inlet of water flow in the sump tank. Moving on, the second step is that we need to calculate the average velocity, where the formula for average velocity is that we will use the flow rate to divide with the area of pipe, and later on we'll get the value of average velocity to be 0.5147 meter per second. Okay, moving on, for the third step is that we need to calculate the Reynolds number, as we need to determine the type of flow in this system. And we already assume the water to be 25 degrees Celsius and the density is 997 kg per meter cube, and the mu will be 0.891 times with 10 to the power -3 kg per meter per second. And we apply all these data into the Reynolds number formula, and we will get the value of Reynolds number to be larger than 4000, and we can make a conclusion that this flow is turbulent flow. And next, move on to the fourth step, is that we calculate the roughness, where we already assume we use the CPVC pipe, and the roughness of the pipe will be 0.0015 mm, and we apply it to calculate the roughness. Then we need to divide it by the diameter of the pipe, and lastly we get the value of roughness to be 6 times 10 to the power -5. After that, we need to calculate the friction factor, and we apply the Colbert equation to determine it. So in this Colbert equation, we need to insert two values, which are the Reynolds number and also the roughness of pipe, and these two values we already obtained from the previous calculation, and we just insert it. So finally we get the friction factor to be 0.0281. Moving on to the step number 6, where we need to calculate the loss coefficient KL. And based on the table, we got 4 types of pipe, which are the T connector, the 90° smooth band, the ball valve, and also the pipe connector. And beside that is the amount in the piping system. And another beside one is the loss coefficient value for each type of pipe. And when we total it out, we will get the loss coefficient to be 23.1. Moving on to the step number 7, we need to calculate the total length of pipe. And we total it out, we will get the final total length of pipe to be 61.556 meter. Okay, so now we come to step number 8, where we need to calculate the head loss, HL. And first we need to apply the formula of HL, and inside the formula we need to insert two values that we obtained from the previous calculation, which are the friction factor and also total coefficient loss. And finally we get the head loss to be 1.2459 meter. Moving on to step number 9, we need to calculate the head pump, and in order to determine the equation of head pump, we need to start from the Bernoulli equation. And so these are the Bernoulli equation, and we need to cancel all the unwanted terms. And finally we get the equation of head pump to be Z2 plus with the head loss. Okay, so if we refer to the equation of the head pump, we already know the value of head loss, but we still don't know the value of Z2. So for Z2, we need to use the water depth of the fish tank minus with the water depth of the sump tank, and we get the Z2 value to be 0.2276 meter. And we need to insert it into the equation of head pump along with the head loss value, and we get the value of head pump to be 1.4735 meter. Since we already get the head pump value, we can directly calculate the power of pump, and we apply it into a formula, and finally we get the power of pump to be 3.641 watt. Okay, so now we need to calculate the value of MPSH available, and we need to assume the water to be 25 degrees Celsius, so the vapor pressure at 25 degrees Celsius are 3.169 kilopascal, and we can apply it into the formula to find the MPSH available. And finally we get the value of MPSH available to be 10.6973 meter. Okay, so lastly we need to calculate the total volume of water in the whole system, but beside that we need to calculate the total volume of water from each tank first. So for the fish tank, the volume of water will be 1.4121 meter cube, and for the sump tank, the volume of water will be 0.5663 meter cube. Next, for the small cylindrical tank, the volume of water will be 0.0358 meter cube. And lastly, the 200 gallon cylindrical tank, we just convert the volume from gallon to meter cube, and we get the 0.7571 meter cube. Okay, so after we calculate the total volume of water from each tank, now we need to determine the amount of each tank in this system. So after from the surveying, we get to know that we have 12 fish tank, 1 sump tank, 4 200 gallon cylindrical tank, and also 4 small cylindrical tank in this recirculation aquaculture system. And finally we just times the volume of 10, and finally we get the total volume of water in the whole system to be 20.6831 meter cube.
Okay, now we move on to the discussion part. In discussion, in this recirculation aquaculture system, we choose CPVC pipe as the main component to construct the piping network. This pipe can bring a lot of advantages to the piping network in this system, where it is resistant to corrosion, easy to install in the system, resist to heat, and it has affordable price, and light and have low energy. And the diameter of this pipe must be larger than 25 mm to avoid clogging. Okay, so the comparison of pump. Our group chose 3 models to compare each pump. First model is KSA55AE, second ACM75, third PSP70/037. And all these models have the same type of pump, which is centrifugal pump. And the power for each model is, for the first model is 350 watts, second 750 watts, and third model have 370 watts. So these all models have the same voltage, which is 240 volts. And for the maximum flow rate, the second model have the highest maximum flow rate, which is 100 liters per minute, while third model have the lowest, which is 220 liters per minute. And for the NPSH required, for the first and second model have the same value, which is 9, and for the third model have 8. And the price for each model, the most expensive is the third model, which is 710 ringgit. For the second model, we have 399, and the first model have 139 ringgit. So these are the comparison between all these pumps. So we move on to the chart. So this chart is to find the head pump from the flow rate that we have calculated. So first we will plot one vertical straight line on the flow rate that we had calculated, which is 15.1584 liters per minute. And after that, we draw the horizontal line that pass through the ACM75, this one. So we will draw the horizontal line on that. And after we draw the line on this, the horizontal line, we obtain the head pump from the flow rate that we had calculated before, which is 34 meters. So this is how we find the head pump using this chart. So for the discussion, after all the discussion, we select ACM75 single impeller centrifugal pump as the Recirculation Aquaculture System pump. Thus, the cast iron pump materials and support under special anti-rust treatment. It built-in thermal protector for single-phase motor, and it able to sustain at liquid temperature, which is 60 degrees Celsius, and ambient temperature is 40 degrees Celsius. And this pump have large capacity to produce flow rate up to 100 liters per minute.
Okay, thank you, Kai. So now I will continue with the conclusion part. Okay, so based on the discussion just now, from the 3 pumps that we compare, so our group can conclude that the most suitable pump to be installed in this recirculation aquaculture system will be this model, and with the market price of 399 ringgit. The model of this pump is Leo SCM75 centrifugal water pump. Okay, so in order to understand why we choose the SCM75 water pump as our final decision on the most suitable pump to be installed in the recirculation aquaculture system, now we will compare between the value from the calculation and also the value from the SM75 parameter. So if from the power, we can know that the power that we have calculated only 3.641 watt, but the power available from that pump SCM75 is up until 750 watt. So if we compare between the flow rate, The flow rate we have calculated is 15.515 at 4 liters per minute. And while for the flow rate inside the SCM75 pump, it can up until 100 liters per minute. And next, the third specification is that the head pump. So for the head pump that can be provided by the SCM75 water pump is up until 34 meter, while for the head pump that we have calculated is only 1.4735 meter, which is quite small. And lastly, we compare between MPSH. So the MPSH value from the pump must always be lower than the MPSH available, which means MPSH required must be lower than MPSH available. So from the calculation, we calculate the MPSH available is 10.6973 meter. So the MPSH from the pump that we choose must be lower than that. So for this one, the SCM75 one, the MPSH required value is at meter, which is lower than the calculated one. So that's the reason why our group chose the SCM75 pump as our final decision. Okay, so that's all from us. Thank you.